Imagine being able to predict the health crisis as straightforward as we can forecast the weather. How could this affect the future of our public health? Let's dive into the revolution of AI and geospatial technologies, or GeoAI, and see let's identify what are some of the gaps that we need to fill in order to make this happen. So in this video, I will talk about three types of gaps. First, I'll talk about application gaps. What are some of the applications of GeoAI towards public health? And what are some of the things that maybe we can do lots of things, but we're not quite there yet. Then I'll talk about data's role in public health and improve public health outcomes and identify some of the data gaps. Then I'll talk about an overall knowledge gap that I feel like if we can fill this, it'll really turn the stream into a reality. And then after I talk about these three gaps, I will highlight GeoAI and why I feel like it's a main driver for this comprehensive improved public health. So quickly, a little bit about me. Early on in my career, I was at MapQuest, and I was around some really smart people who were doing some really revolutionary things to put route directions online. And there at MapQuest, I saw the power of programming in databases. I said, I really need to learn programming in databases. So I saw how they can really scale up our analysis to solve some of these challenging problems. Then at Esri, when I was at my time at Esri, again, I was around really smart people from both a geospatial background, but also computer science, computer engineering, other technical domains. And I saw this interdisciplinary, doing some interdisciplinary mentality to create some really amazing web applications at that time. And then also too, I spent 15 years around some really amazing lifelong learning research professionals. So in the research sector, and this being around these people really taught me the value. Now I have this really interdisciplinary mindset and skill set. So first, let's address what are the application gaps. Where are the places that GeoAI can really help us, but maybe we're not quite there yet. First of all, disease surveillance and prediction. So there are many successful individual applications. Most commonly, though, on addressing a concise problem, whether it be predicting a disease outbreak worldwide, but then at a coarse granularity. We saw this in the pandemic. The pandemic really advanced a lot of our thinking with disease monitoring and prediction. Or the other possibility is predictions, but more on a local level, and maybe also too not like on this sort of like a kind of like real time prediction. So this is something that I feel like is lacking but also too that GeoAI can really help is fusing really diverse data sets and having these comprehensive data variables and being able to predict disease spread, but globally at a large geographic area, but maintaining this local preciseness. So also too, GeoAI can really help this because when you're trying to address a problem like this, you'll very quickly get like big data. This is a big data challenge, and the big data really quickly outpaces human cognition. So this is really where the GeoAI comes in to help us make sense of all of this data. Healthcare accessibility. So there's many regions in the world where healthcare is not accessible, especially in low-income countries or even rural areas in high-income countries. So GeoAI, can really help us map some of these, let's say healthcare deserts, and then also to optimize the, when we try to when we do dedicate resources, how do we optimize the placement of these resources to make sure that everybody has equitable access to healthcare? So personalized medicine. So treatments and healthcare practices where we really factor in the individual genetic profiles, lifestyles, environments that people live. This is where GeoAI can take, once again, like really vast data sets and diverse data sets, put everything together and give these some of the, identify some of the patterns, and then give personalized recommendations based upon some of these patterns. So social determinants of health. What are the things that determine our health? Along with genetics. So what's our socioeconomic status? What's our education level? What's the neighborhood we live in? What's our physical environment? Are there pollutants? What type of employment do we have? These are all things that we can all put together fusing data with GeoAI, having comprehensive comprehensive analysis of some of the social determinants of health is something that I feel like GeoAI can really advance. Chronic disease management. So for some of the chronic diseases that are becoming the rise of some of these chronic diseases like high blood pressure, things related to weight management, also to some of the mental health issues. GeoAI can take these diverse data sets, identify patterns, but also add in a personalized patient data in order to give targeted support. And also too, we can identify some of the geographic hotspots so that then we can give like targeted health for targeted health programs and targeted health efforts in public health. Environmental health risks. So this is really, really important, and once again, a really perfect application of GeoAI, because GeoAI is really well adept at taking data sets like remotely sensed data, Internet of Things sensors, identifying what are the main problems in our environment that are affecting our health, both in the case of monitoring and in the case of prediction. NVIDIA recently, announced an Earth 2, where they're simulating the Earth's weather and modeling Earth's weather, predicting the Earth's weather on a global scale and really, really accurately and precisely. I could also see something like this being really valuable for monitoring our environment and some of the health risks. I mentioned this earlier, but mental health services. So both the availability and accessibility of mental health services, it's really, it's insufficient in many cases and really varied. So again, GeoAI can really help with identifying some of the personal care approaches and also to some of the early intervention. A lot of it comes down to the person expressing themselves properly. And however, what we can do is really identify some of our overall public health, mental health conditions, so that we can address resources in certain areas. Some of the global health inequities. So identifying where are the areas that perhaps don't get enough resources for healthcare, and so not only identification, but using again this geo in the AI to optimize when we do provide resources to improve some of these inequities. How can we address the most critical areas to get the most return on investment? And finally, emergency response and disaster management. This is something I research a lot in my career. We spent a lot of time how to use geovisual analytics, natural language processing, bringing in really diverse data sets for emergency response and disaster management. So whenever there's either a natural disaster or a man-made disaster, let's say in the case of natural hurricanes or man-made in the time of war, almost immediately following after this, you would have a health crisis. So GeoAI can help with both disaster preparedness, and then also too optimizing response strategies for after a disaster occurs, so that we can manage some of the logistics behind it, so that okay, well, we had this natural disaster, but let's try to minimize some of the health impact afterwards. Okay, so we talked about the application gaps. Let's talk about the role of data in filling these gaps, and also to identify some of the gaps in the data itself. So first of all, data is really valuable in the predominant machine learning type right now, which is supervised learning. So in supervised learning, you need really high quality data, unbiased data, accurate data to train your model on. And of course, you need accurate labeled examples. And the data that you predict on also needs to be accurate and clean. But also too with generative AI, data that we train our models on need to be really accurate, comprehensive, but also unbiased. Um, we as human, we have a lot of biases and we have a lot of generalizations that are often untrue. But if we can train models, AI models, on accurate data, unbiased data, comprehensive data, then in the end, what we get is we get straightforward, data-driven, fact-based decisions. So this is why data plays a critical role in outcomes of health interventions, analyses, and our decision-making processes. So when accurate and comprehensive data is used, we get accurate insights and analysis, and we get like a deeper understanding of health issues. We get effective health interventions. We can precisely target and tailor the needs of specific populations. We can maximize the impact and efficiency of our efforts. We get improved public health outcomes, like a collectively reduced disease and mortality rates through better informed decisions. We get better resource optimization. We're efficient in allocating our resources. This can avoid waste as well. And we get focused interventions. So we get this return on investment. We get increased trust and credibility. So between the stakeholders and public health institutions, and we get enhanced public cooperation and support if we make these fact-based decisions that are trustworthy. However, if we use messy, error-prone data in our analysis, then we get misguided decisions, wasted resources, poor public health outcomes, erosion of trust, and basically difficulty in evaluating and adjusting our future goals. So these really highlight the importance of investing in our data, accurate data collection, accurate data management, and in the end, accurate analysis to support our public health initiatives. So I think it's really important to point out that it's not just in the data collection process that we have to be really careful and accurate, but also too in our processing techniques. We need quality, comprehensive, and transparent data processing techniques. In a previous video, I talked about some of the awesome, really amazing data sets behind like World Pop, where they have these global population demographic data sets. So one thing that one of the other reasons why I like World Pop is they're really transparent on their methods, and they provide many metrics that give us confidence in their processing techniques. So that then in the end, when we use their data for other analysis, then we have confidence in our results. So now let's talk about some of the data gaps. So I think one of the obvious ones is that most people think about is the quality and control of some of the existing data, also to some of the data that we're planning to collect. The data needs to be accurate, complete, avoid biases. So that's sort of one gap is we're not there. It's obvious that we're not there, right? So much of the data we collect is not accurate, and so having these data governance systems in place is really important. Also, in quality assurance, quality control is really important. Two is a gap in the topics and attributes of our data. So more health topics, healthcare results, healthcare facility data. The more comprehensive the attributes, the more topics and data. Obviously, that this is for the better. It really allows us to solve more problems. But now maybe too, also a little bit less obvious is some of the geospatial gaps. So in the US, we have like, even though obviously we have lots of gaps, we have some of the best data. We have, really complete coverage. We have lots of data options, but this is really not the case in other parts of the world. So, and I'm mentioning the United States, but obviously we have a long way to go with filling some of these geospatial gaps. So, on a recent project for World Health Organization, I was trying to use some data where it was about education levels, but the problem was that data was on the country level, and I was trying to do my analysis and predictions on a local level, and so that data really didn't help too much. Temporal, along the same lines, geospatial gaps, but temporal gaps. So, data that data that we collect once, and then it quickly gets out of date as our environment changes. We need to really fill in some of these temporal gaps. So especially the last two, which I'm saying is less obvious, is where I feel like GeoAI can really be of value. So filling these gaps, especially the geospatial gap and the temporal gap, this is something where GeoAI I feel is really valuable, because we can take some of our existing data and either predict or interpolate to fill in some of the other gaps. And with the data fusion, we can fuse other diverse data sets that helps us generate comprehensive data sets. And also, too, temporally, if some of our data is analyzed and processed, collected through sensors that give us either real-time data or in the case of remotely sensed data every day, every couple of days. This is really important for filling in some of these geospatial and temporal gaps. Okay, so now I've talked about, first of all, application gaps. What are some of the applications that, if we fill these, it would be really valuable, and something that GeoAI is well set up to fill. What is data's role, and what are some of the data gaps in accomplishing what we want? So now let's talk about one overall knowledge gap that I feel like needs to be filled. And if we fill this, it will really, in my mind, propel us to reach our goals. So there are geospatial companies like Esri, Mapbox, Carto, Descartes Labs, Earth observation companies like Maxar, Planet Labs. I really like this company, Black Shark, in Europe. They're doing good things. And we have big tech companies like Google with Earth Engine, Microsoft with their planetary computer, that all of them are creating geospatial, are making some geospatial analysis techniques more readily accessible to geospatial professionals, computer scientists, lots of different types of scientists. However, to solve some of these really complex health challenges, I feel like you really need a deep understanding of geospatial data, its many sources, how to store, process, fuse that data with other data, that in the end, the data and results that you're getting are accurate. It's still representative of your problem, and the results are accurate. And geospatial analysis techniques, how to correctly apply them. If your data is vector, raster, time series, scattered or dense, how do we apply these analysis techniques so that we get accurate results? And also, too, how do we interpret them? What are the ways? How do we accurately interpret these analysis techniques? Vice versa. So lots of these companies are making AI more accessible to non-experts, non computer scientists, non data scientists. So Esri's making spatial clustering tools. There's deep learning for feature extraction, land classification, even auto ML. So automated machine learning. So when you have a machine learning designed to pick your best model, optimize your hyperparameters, even do some of the data augmentation and preprocessing steps, You also too have some of these big companies, Google, Microsoft, Amazon, AWS is with natural language processing, offering natural language processing services. However, once again, I feel like if you don't have this deep understanding of the artificial intelligence, then I feel like you're only going to be, I mean, for one, the analysis will be more difficult, and maybe it's also too not going to be correct, but also too, you'll only be scratching of the surface. I feel with both. If you have only a surface understanding of geospatial, you only have a surface understanding of AI. I feel like you'll only be scratching the surface of what is actually possible, the problems to solve when if you have a really strong interdisciplinary mindset and skill set. So why does this knowledge gap exist? And here I'm talking about the knowledge gap with geospatial and AI. However, this could apply to so many different domains where you're trying to address problems. If you have this interdisciplinary mindset, you bring in AI in business or geospatial in business. Whatever the problem you're trying to solve, I'm focusing on the GeoAI aspect. But if you have this interdisciplinary mindset, this lifelong learning mindset, um, it will be really, really valuable to solving real world problems. So first of all, why does this exist? Is that, I mean, obviously there's only so much people can learn and teach. And so therefore, for example, in many of our universities, there's little overlap between the geospatial and the computer science. However, there are places where people are exposed to both regularly. I was really blessed again to be be at the research center that I was at Penn State University, where we had student and faculty from really both sides and other domains. So you had computer scientists learning geospatial techniques. You had geospatial people learning computer science and even AI. So two example people that I really deeply respect, that really I feel like really I learned a lot from them, and they're really good role models. So Dr. Alan McEachran, he began his career. He basically kind of like what you say, in a sense, wrote the book on cartography early in his career. However, then he continued to, as a lifelong learner, he continued to advance. New technology came along, and then by the end of his career, he was even an affiliate professor at the neighboring College of Information Sciences and Technology. And from the other end, another person that a colleague friend that I really deeply respect, Dr. Prasenjit Mitra. So his background is in computer science. He got electrical engineering PhD at Stanford. Spent some time working on databases at Oracle. However, when he was working with us at Penn State, he continued learning, really soaked in so much of this geospatial technology knowledge that actually now much of his research is focused on using geospatial technologies, once again combined with artificial intelligence, other data analytics to solve real world problems. And I would also too be remiss if I didn't mention some of the students who came through our program that really are doing some amazing things. Did some amazing things afterwards. Brian Tomaszewski, who's now at Rochester Institute of Technology, Morteza Karimzadeh at Colorado, Wei Lo at National University of Singapore, Arif Masur at ISRI, also to Senju. He did a lot of work with Uber and Lyft on self-driving cars. So these are all from the geospatial side that got really, 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 really embraced this interdisciplinary mindset. But then also too from the other side, computer science side, Anush Jaiswal, Siddhartha Banerjee, who really, really soaked in some of the geospatial analysis. Now, I mentioned that there's that this is not necessarily the norm, but there are some other places that I know of that are doing really, really good with this interdisciplinary knowledge and mindset. University of Wisconsin, University of California, Santa Barbara, University of Twente in Netherlands, University College London. Really solid interdisciplinary education, both education and experiences. Also, too, England's Alan Turing Institute for the nationwide AI and advancement is really promising that so many of the people focused on using AI to solve real world problems have a lot of expertise in geospatial technologies. So the purpose of this talk, the reason I'm giving some of these examples, is really to encourage this interdisciplinary approach to solving some of these complex challenges that we're faced, and sort of like teaching a mentality for lifelong learning. The examples I gave, unfortunately, I feel like are still a little bit abnormal, where your educational programs are fairly distinct. What's GeoAI's role in filling these gaps? So very quickly, I don't want to spend too much time, but because I went in depth on another video about this. So for one, on the geospatial side, the role of going back to the first law of geography, everything is related to everything else, but near things are more related to us. This really helps with, especially in the world of public health, where things around us, our environment, our neighbors, are really critical to our public health. So this is really important. Also, too, the fact that this geospatial data provides this natural SQL join, so we can fuse so many diverse data sets by location, really helps our analysis and our results in our problem solving. And also, too, the fact that it's an inherent visualization really helps with both our analysis and conveying our results to the people who it's really our audience, the people that's really important. And why is AI and geospatial such a good fit? Because when you're doing this data fusion, where you have lots of different sensors that are collecting data on a scale, you're fusing that data. It's really easy to get big data. We've in the geospatial world, we've had a big data problem for a really long time. So AI is really good at taking these diverse data sets, these big data sets, summarizing them, uncovering patterns, extracting meaning, making predictions, generating content, automating tasks, and really most importantly, really most importantly, is doing all of this in fractions of a second. Things that in the past would take a really long time, months, years, it can now do in fractions of a second. So getting back to this, when something happens, we're ready to take action. So just again, some quick examples of this is fusing diverse data sets by location to better understand and predict disease spread. Scaling up our data sets geographically and temporally, either through predictions or interpolations. Creating or also to using these analysis techniques to create new data sets from other data sets. Understanding the importance of location and our environment, the people around us towards analysis, our neighbors, as far as like public health, disease spread. Understanding the importance of both natural and man-made disease spreaders, like rivers, transportation networks, constraints like country borders, water bodies that are not easily crossed. This is really important. Optimizing what we are trying to accomplish. So whether it be any sort of allocating resources, understanding the really complicated like human, man-made, and natural environment interactions that we live in. So GeoAI can really provide this comprehensive system. So a lot of the application gaps I mentioned earlier, of course we're addressing them, but not in a comprehensive way. So I feel like GeoAI is really set up for the future to address these applications in a comprehensive way and provide comprehensive solutions. So now I'd like to talk about a use case, just one use case, which kind of illustrates the power of GeoAI for public health. So what's important about this use case as well is the process used in this use case could really apply to so many other problems and challenges. And this example is using GeoAI for smart and healthy cities and for urban management and sustainability efforts. And in this particular case, I'm talking about intelligent mapping, identification, mapping, and monitoring of insect breeding sites. So the objective of this, again, this use case for identifying and monitoring mosquito breeding sites is to reduce the risk of some of the outbreaks in both in smart cities and rural areas by identifying and controlling the breeding sites using GeoAI. So now, after identifying our objective, the second step is to get our data. So satellite imagery, high resolution satellite imagery, both whether it be visual or optical or also to infrared, things like this. Satellite data that's relevant to identifying some of the possible, where do mosquitoes generally like to breed. So these provide a comprehensive view of potential breeding sites. Stagnant water. We can locate stagnant water bodies, unattended green spaces, urban waste sites. And then once we have our satellite data, then we can fuse with that by location sensor data. So we can deploy Internet of Things sensors to collect real-time data about things like humidity, temperature, other conditions that make it conducive to insect breeding. So then we gather historical data. So where do we know that there's breeding sites? Where were there past disease outbreaks? Where were there previous infestation sites? And sometimes too, this data can be collected through citizen science. Sometimes citizen science is really valuable for collecting data. So there's some examples online that show this data collection and identification process. Esri has one online which talks about some of the work they did with collaborators in DC for mapping mosquito breeding sites in DC. But what GeoAI can do is really scale this type of work. So then the next step after you have your data is processing. So pre-processing, cleaning, removing noise and irrelevant information. If you have data that's incomplete, you either fill it in or you remove it. Also to some of the normalization steps to make sure that the data is consistent, that we don't have certain data that that's then more or less important than it actually is to the real world problem, and also to feature extraction. So we can pre-process the satellite data. We can extract water bodies, extract green spaces, things, other vegetation, things that are important to identifying mosquito breeding sites. So then it comes time to develop and train our model. So once again, the predominant machine learning technique is machine learning. What you say type is supervised learning. So the whole idea of supervised learning is that you give a model past examples of what you're looking for, along with the factors that are important to making that past example happen. And then you train your a lot of times, especially when you're working with imagery, deep learning models like convolutional neural networks, also to RCNNs, region-based CNNs. I had a lot of success with those for actually training a model to automatically map oil spills. These are really valuable. These work really well on satellite imagery. So you give these models past examples, train the model, and then therefore you're able to predict other examples over a much larger area. So this process is really valuable for, say your goal is to map and identify all of the mosquito breeding sites, or have a good idea of all the mosquito breeding sites on a large scale, like a large geographic scale. So then you would utilize this process. So you have some examples that you know really well. You train a model, and then you use that model to predict on a much larger geographic scale. So then once you make your prediction, it's important to note that this is an iterative process. So you would make your prediction, you would have more mosquito breeding sites, but then you validate those sites. And a lot of times that involves taking a sample, checking it by either using your, like we say, innate, as humans, we have this innate ability to take really, really uh, diverse data and contextual information to figure out problems. So we, as a person, we might be able to go to look at the satellite imagery, look at the sensor data, look at other data, and figure out whether it's a breeding site or not. We can do this innately. So then we can do it like that, or maybe too, you'll have to actually go to the place, go to the location, and decide if it's a breeding site or not. And sometimes too, this can, like I mentioned before, this can be done through citizen science. So to do this is really time consuming. Although it is important to note, the more you do it, the better your model will get, the better your predictions will get, and the less you have to do it. So because this is also time consuming, there's techniques that help us out. And the main family of techniques is known as active machine learning. So in this case, some of the techniques might be you take your predictions, and then you only look at the ones where the model is most unsure. So a machine learning model gives a probability, whether it's a breeding site or not. So you would take the ones where it's most unsure, like around 0.5, and those are the ones you look at. Or another strategy in active learning is you train multiple models, different types of models. You let multiple models predict sites, and then you choose the ones that the models disagree on the most. So these types of techniques are really, really important, can be really important to identify the labeled data, that when you correct this labeled data, the model can learn at a much faster rate, and you can reduce a lot of the human time, the time-consuming human labeling. So now we've trained our model, we've gotten our model really, really solid, and now we deploy our model. So we deploy our model through predictive mapping. We use this trained model to then comprehensively predict other mosquito breeding sites. We generate these maps highlighting the areas for targeted intervention. And also, too, we can do real-time. What's really important is we can do real-time monitoring. So incorporating remotely sensed data, IoT sensors, we can continuously update our model, both in the sense to improve the model, but also to get this real-time predictions. After we deploy our model, we then get into some of the actionable insights. So we set up automated alerts, alerting, bringing in other systems, alerting city and health officials on some of the high risk areas. How do we allocate our resource properly if it's spraying insecticides, if the mosquito breeding sites are being caused by human waste, human trash, we need to clean this up. And also to public awareness, making the public aware of what we're doing, both in the sense to get some assistance, but once again build this trust that what we're doing is making a difference. And then, kind of like what I mentioned earlier, I mean, this is a continuous process. So you'll continually be getting updates on your imagery, your sensors. You refine your predictions. You adapt to the changing environment, the changing conditions, and you allow for this human in the loop, methodology where you can measure the effectiveness not only of your predictions but of your system. So when you take action, how does this affect your overall goal of controlling mosquito breeding sites? In summary, GeoAI is really important to this particular use case, and so many, like I said, so many other use cases, like identifying and mapping environmental plastics, identifying risky environmental areas, illegal waste and trash dumping. So many other applications could be solved in a similar manner. Not necessarily solved, but mapped and analyzed, mapped and documented for action. But the one most important thing is for GeoAI is scaling up our documentation, our us mapping and analyzing these sites, scaling up both in the sense geographically and temporally. So this goes to the second most important point is the speed at which we can now make our predictions. So in the past, something like this would take many, many months, if not years, to do, or maybe it's not even feasible. But even then, too, after you do it, you kind of get like a point in time. So, but now once you have your model, and you can do this you can make your updates on a regular basis. Our environment changes regularly. We have seasonal variation. We have, daily variations, weekly variations, seasonal variations, yearly variations, things like droughts. We also have slower climate change induced variations. But also we have catastrophic events like natural disasters. So having this ability to very quickly update our data through GeoAI, other analytics techniques, this is really, really valuable that we have our model in place. A natural disaster comes along, a hurricane comes along, and immediately we can update our data so that we know, okay, these sites have a high probability of becoming mosquito breeding sites. And so we can address these quickly so that, okay, we had this natural disaster, but now we can possibly lessen some of the potential extra. This is just one particular use case for GeoAI and public health. But I think you can see from this use case why I'm stressing the importance of this interdisciplinary knowledge. For this use case, you need that scientific knowledge about mosquitoes and the factors that influence their breeding sites. You need knowledge about modern mapping techniques, geospatial data, remotely assessed data, sensors like GPS. You need to be able to store and process all of this data. You need to know about the analytics, the geospatial analytics, that when done properly, the data still reflects the real world. I had a social studies teacher way back in early in my high school career. He said this thing that stuck with me: figures don't lie, but liars figure. And so you can either purposely manipulate your data where it's doesn't realistically show the true meaning, or you can also unintentionally, by mistake, if you don't know what you're doing, manipulate your data where it's not representative of what you're actually what the data is about. Also, too, you need to know about the AI, machine learning, and data science techniques. This collective data science techniques, how to use them to model, how to evaluate your model. So, what are the proper depending on the way you set up the problem, machine learning problem? What are the proper metrics to evaluate your model so that you know that your results are accurate and generalizable? Also, too, now you have to know about visualization and cartography techniques, so that then you can accurately convey your results to the audience and decision makers. And then finally, also too, if you want to put all of this, all of your results into a web application, you need to know about web application development and building dashboards. So I think this use case also illustrates the power of the importance of this interdisciplinary knowledge. So this particular use case really kind of hits home for me because when I was doing my master's degree at University of South Carolina, I spent one summer. I was working with the county there, Richland County, where Columbia, South Carolina is, and they were mapping with really detail all of the mosquito breeding sites. So they had some historical knowledge about where these sites were. Most commonly descriptions or things like addresses. But then me and another guy were going out with these big GPS antennas on our backs, getting really precise locations for these mosquito breeding sites. And then keep in mind, this was South Carolina in the summer and the heat and humidity going into mosquito breeding sites. So after that, I was kind of like, I really, really need to learn programming and data analytics so that because I'd really prefer a climate control office. However, maybe now, knowing what I know now, maybe I can lessen some of this, this type of burden off, in order to still create these types of data sets, but also to now scale this type of data collection. And then also too, I have a recent project with the World Health Organization where I was using a lot of these similar techniques for data fusion, data analytics, machine learning to make predictions for data related to disease spread, lots of different diseases, and what are the important factors? Can we predict disease spread? And doing this on a massive continental scale while maintaining this local precision. So once again, this is something GeoAI is really good at, scaling up your analysis and being able to create such a model where then updates can be made on a regular basis, a timely basis, weekly basis. And then also too, in the past, I worked on a CDC funded project, which was geovisual analytics, applying geovisual analytics techniques to understand cancer rates across the United States. And then also too, there's another NGA and DHS funded project, which was which the goal was making sense out of unstructured data towards public health, which was mainly media news articles, analyzing some of the places being talked about in disease, providing interface to search and filter, and what are some of the connections related to disease. So in my career, my expertise has sort of spanned, from the start: cartography, GIS, remote sensing, digital mapping, mobile mapping, location-based services, visual analytics, big data storage, big data analytics, AI, machine learning, data science, and also to most commonly applied research to really focusing on solving some of the real world problems. So if this video interests you and any of the technologies that I mentioned, you feel like you think they can improve some of your own public health challenges, please reach out to me. I feel like we can really together shape the future of public health together. So in this video, I talked about the current landscape of GeoAI, some of the application gaps where we're making good progress, but maybe we're not quite there, especially on a comprehensive level. What is data's role, and what are some of the data gaps? And also, too, I focused on a big, kind of overarching knowledge gap. I feel like that if we can really address it, we'll really speed improvement and help some of our future public health. And I highlighted GeoAI's role and importance in filling these gaps. So thank you very much for joining me when I talk about the power of GeoAI towards, GeoAI's role towards improved public health outcomes. If you're moved to make a difference, let's connect. Subscribe and share your thoughts. Reach out to me by either through social media or through email. And I feel like the future is ripe with opportunity where we can all succeed and improve public health together.